Tanzania, asante Nyerere baba, tunajivunia upendo wetu na amani, tena pia Mugabe bendera baba, tunajivunia upendo wetu na amani.
Us on #LearnOn1. Tell us what you're learning and where you're learning it from. Send us your name and town to the One Africa TV's WhatsApp on 081-200-6659 or send an SMS to 555. One Africa TV. It just gets better.
To make sure that we write our equation correctly, now we have to balance the equation and we check the numbers of the atoms on both sides. A good advice is it's better not to begin with oxygen or hydrogen, usually. So what other atom do we have here to begin? Let's start with a tin atom. How many tin atoms we have on the left? We have just one. Let's go to the other side. How many atoms do we have of, how many atoms of tin appear? It's also one. So tin and tin here seems to be balanced. On this side, we see that this tin, though, is combined with oxygen. So let us check now the oxygen as the next step. Oxygen, we have 2 atoms of oxygen here. What do we have here? Oxygen appears only in water. And there is only one oxygen. So what we need to do now, in order for us to have the same number of oxygen atoms, let's place a 2 in front of the water molecule. That gives me 2 oxygen to make it equal to this oxygens on that side. All right, so it seems that oxygen atoms are balanced now. We have 2 oxygens here because we made it to be 2 molecules of water, and 2 atoms here on the tin oxide. Now, oxygen, though, here in this compound is attached to hydrogen. Let's check now the number of hydrogens. It's the turn of the hydrogen now. How many atoms of hydrogen we have now? And we must remember that now we have these 2 here. It means 2 water molecules. So in 2 water molecules, I have 2 times 2, 4 hydrogens. We have 4 hydrogens here. On that side now, where do we have the hydrogen appearing? It appears only here, on the hydrogen molecule. But now 4 hydrogen atoms, and here we only have 2 hydrogen atoms. So what we need to do is multiply this by 2, and we will place a 2 before the hydrogen molecule. And now we have 2 times 2 hydrogen molecules. We also have 4 hydrogen molecules as well. Let's summarize all that in a table. So we had tin atoms, the type of atoms. Let's write the type of atoms. We had tin, and we had oxygen, and we had hydrogen on both sides. So on the left-hand side and on the right-hand side, let's start from the left-hand side. How many tin atoms do we have here now? We have 1 tin atom. How many tin atoms we have now on the other side? Also 1. Oxygen. We have 2 oxygen atoms on the left-hand side. We have 2 oxygen atoms. And here we have also 2 oxygen atoms. Finally, the hydrogen. we have, on the left-hand side, we have 2 molecules with 2 atoms each. It's 4 hydrogens. And on the other side, again, we have 2 times 2, 4 hydrogen atoms. Again, 4. So we see the numbers on the numbers of each atom on the left and right-hand side are the same. And once this is correct, once these numbers are the same, the equation is balanced. My equation is balanced. So, in other words, when we balance an equation, so how we balance a chemical equation? By adding certain coefficients in front of different items as necessary in order for the number of atoms of every element on the left to be equal to the number of atoms of every element of this corresponding element on the right. But the chemical equation is not yet finished. There is one more task to do. And this task now is we need to specify in front of each item that appears in the reactants and the product, the state of these items. For example, this is an oxide, tin oxide. The tin oxides usually are solids. So we have to say that this is in a solid state, and we represent the state at the end of each item inside the parentheses. So for solids, we use the symbol S inside the parentheses. The hydrogen is gas because they tell us hydrogen gas. So we know that this is gas. The gas is represented by G for gas inside the parentheses. The tin metal is solid. So the representation of solid is this again. The water turns out in the form of water vapor because they tell us water vapor, which means the water vapor is gas. So this is not a liquid, be careful. This will be gas in its gaseous state. Water vapor is water, it's gaseous water in the gaseous state. Sometimes in other reactions, we might have water appearing in a liquid form. For liquid water, we just represent it with the symbol L. And also, in some reactions we're going to come across, there are items which are dissolved in water, in solution. And in this case, for example, say we have sulfuric acid in solution. We symbolize it as aqueous with AQ. This will represent the symbol of a solution in water. So these are the symbols that we have to add on the right-hand side of products and reactants to identify the state of these items. Which means, again, now there is a complication here. How about if we don't know the state of these reactants and products? Well, usually in a problem, they tell us, and we figure it out. For example, it says it's heated with hydrogen gas. They tell us that this hydrogen is in a gaseous state. To form tin metal, well, usually we know that metals appear in solid form, except for mercury, which is liquid in room temperature. So we know from experience and that tin must be solid. We also know that oxides, we have to know that usually oxides are solids. And they tell us that the water is water vapor, so we knew that there is a gas. If the problem we have does not give us enough information, means that we need to know the properties of these items appearing here and the conditions of the reaction, and we need to have quite some knowledge background to write down the states. But usually in the reactions that we are going to see, there is going to be information to help us. We were at this point writing down the equation for this chemical reaction that was given in this example. We might think that we are finished, but we are not finished yet. We have the coefficients, the correct coefficients, so that the number of atoms on the left and right are equal. And now, a third step that we need to take to complete our reaction is that we need to write down the state, to identify the state of each of these reactants and products. What is the state? Whether it's solid, liquid, or gas. If the item, product or reactant, is in a solid state, we place the symbol S in parentheses on the right-hand side of this reactant, for example. The tin oxide is solid. How do I know it's solid? How about if I don't know? Well, oxides are solids, so from experience I know that this must be solid. The hydrogen, they tell us it's a hydrogen gas. Reacts, the tin oxide is heated with hydrogen gas. So they tell us that this is gas. Also, it was not going to be difficult to figure it out if they were not telling us that this is a gas. Then they tell us that forms tin metal. Well, metals in pure form, we know they are solids, unless if it's a mercury, which is a liquid in room temperature. But so tin is solid. And the water, they tell us now, and water vapor, they tell us that the water is in the form of vapor. So this is gas. Water vapor is water in its gaseous phase. So this is gas. So what are the symbols that we use overall? If it's solid, we use an S in parentheses. If it's gas, we use the G for gas. In some other equations, the water is produced as liquid. If the water was liquid, we would place an L inside the parentheses next to the water. And there is also a last case, very important case, of substances which are dissolved in water, in aqueous solution, like sulfuric acid, for example, dissolved in water. Then, if we had sulfuric acid, we would say aqueous, which means it's an aqueous solution of hydrogen sulfate. So these are the symbols that we use to identify, to indicate the state of products and reactants. And remember, we place it on the right-hand side of each item. Now that we have the equation balanced and the symbols correct, and we indicate the state, now this is the correct finished representation of this chemical reaction, of the interaction of those two products. This is now the complete chemical equation reaction. So, to summarize, what have we done here? The first step was to write down the unbalanced chemical equation with the correct symbols. So the first step was to write the unbalanced equation with the correct symbols in symbolic form, let's say, in symbolic form. And we see that this step requires for us to be able to know how to write down, how to symbolize the formulae of different compounds. We need to know where to place the anions and the cations involved. We need to know the valencies of each element appearing. And of course, we need to pay attention where we write the products and the reactants is separated by the arrow in the correct direction. The second step is to balance the equation. And we do that by adding particular coefficients in order for the number of atoms in both sides of the equation to be equal. Remember, the type of atoms and the number of atoms has to be maintained because it represents the conservation laws of charge and mass. So we balance the equation by these coefficients, and be careful, these are coefficients. We don't use them on the right-hand side of different items because we don't want to change the different molecules involved. So these extra numbers to balance the equation are written as coefficients on the left-hand side of each item. So balance the equation. And the third step is to indicate the state of each product and reactant correctly using these symbols here. So these are the three major steps that we need to take to write down a chemical equation to represent the chemical reaction. There is an important aspect here that we need to discuss. Okay, here we had enough information to write down the state of each item. We were told that hydrogen is gas, and the water was vapor in its gaseous phase. If they don't tell us, it means that in order for us to write a correct equation, we need to have an idea of the properties of items involved in a chemical reaction, in order for us to figure out how to indicate the state. For example, they tell us it forms tin metal. They don't say in which state the tin is, but from experience, from our knowledge, we should know that tin, being a metal, has to be solid. We should also know that from experience that the tin oxide is a solid because oxides are solids. And so we need to be familiar with enough background to write down an equation. And sometimes we also need to memorize a few things. For example, we need to memorize how to write correctly a compound that involves polyatomic ions, for example. But there are tables that to help us write down correctly the charge to indicate the charge of polyatomic ions correctly. And slowly, we understand that there are some very common ions involved in different ionic compounds, for example. And we will remember them slowly, one step at a time. It just needs a lot of practice.
Chemical equations representing reactions. When hydrogen gas reacts with oxygen gas, water is formed. This is an example of a synthesis reaction. Let's write down the word equation. The hydrogen gas reacts with oxygen gas to produce water. To write a chemical reaction, we have to write down the formulae and the symbols of our reactants and our products. The formula for hydrogen gas is H2 because it is a diatomic gas, and we write a G to indicate that it is a gas. Similarly, oxygen gas is also a diatomic gas, so it's O2. And again, we write a G for it because it is a gas. You all know that the formula for water is H2O. In this case, it's also going to be a gas because the reaction takes place at high temperatures. Now we have to balance the chemical reaction. On this side, we have 2 hydrogen atoms. On this side, we also have 2 hydrogen atoms. So they are the same. But on this here we have 2 oxygen atoms. Here we only have 1. So we put a 2 in front of the water molecule so that we can get 2 oxygen atoms. Remember, we are not allowed to put a 2 there and change the formula of the compound. But now we have 2 hydrogen atoms here, but we have 2 water molecules. So in total we have 2 times 2, which is 4 hydrogen atoms. So we need to put a 2 in front here so that we have 4 hydrogen atoms in the reactants as well. And our reaction is balanced. When carbon burns in oxygen gas, carbon dioxide is formed. This is also a synthesis reaction. Let's write down the word equation. We have carbon plus oxygen gas, and when the carbon burns in the oxygen gas, it gives us carbon dioxide. To write down the chemical reaction, we write down the symbol of carbon, which is C, and carbon is a solid. It's like charcoal that you braai with. Oxygen gas, you know, is a diatomic molecule, and it is a gas. And the product is carbon dioxide. The di tells us that there are 2 oxygen atoms, that's CO2, and it is also a gas. Here is 1 carbon, 2 oxygens, 2 oxygens, so our reaction is balanced. When the compound mercury oxide is heated, it decomposes into the elements that it is made of. So let's write a word equation. We have mercury oxide. We heat it. And what are our 2 elements? It's mercury, and oxide we know is oxygen. So it decomposes into mercury and oxygen. And you know that oxygen is a gas. Okay, to write the chemical reaction, we have to write down the formula for mercury oxide. The symbol for mercury is Hg, and the symbol for oxygen is O. And you might not know this, but it is a solid. If it decomposes, decomposes into its elements, which is mercury. And hopefully you know that mercury is one of only 2 liquids on the periodic table. And oxygen gas, again it's a diatomic gas, and we have a G there. Let us balance the equation. Here is 1 mercury atom, there is 1 mercury atom, so they are balanced. But here we have 1 oxygen atom, here we have 2 oxygen atoms. So we have to put a 2 in front. Again, remember, we cannot change the formula of the compound. But now we have 2 mercury atoms here, so we will put a coefficient in front here to have 2 mercury atoms in the product as well. So our chemical reaction is balanced. The last decomposition reaction is where the compound copper chloride decomposes into its elements when it undergoes electrolysis. Let's write down a word equation for the reaction. Copper chloride undergoes electrolysis, and then it is decomposed into its 2 elements. What are those 2 elements? It's definitely copper and chloride is chlorine, and chlorine is a gas. Okay, let's write our chemical reaction. The formula for copper chloride is CuCl2. You can refer to another lesson to write the formula of compounds. This is a powder, so it is a solid. The symbol for copper is Cu, and you know that copper is a metal, so it is a solid. And chlorine gas is a diatomic gas, and therefore it is Cl2, and it is a gas. Lastly, we have to balance it. We have 1 copper atom here, we have 1 copper atom here. We have 2 chlorine atoms here, and we have 2 chlorine atoms here. So our reaction is balanced. Balancing equations. Is the following chemical equation balanced? How do we know that it is balanced? Well, we have to count the number of atoms in the reactants and the number of atoms in the products. So let's start on this side. We have a magnesium atom and we only have 1. We have an oxygen atom, we also only have 1. We also only have 1 hydrogen atom and 1 chlorine atom. If we move on to the products, here we have a magnesium atom. Again, we only have 1. But this tells us that we have 2 chlorine atoms. Similarly, this 2 tells us that we have 2 hydrogen atoms, and lastly we can see that we only have 1 oxygen atom. So although the magnesium atoms are the same number and the oxygen atoms have the same number, the hydrogens do not have the same number of atoms, and the chlorine atoms are also not the same. So how can we balance this equation? If we put a 2 in front of the hydrogen chloride, we will get 2 hydrogens in the reactants and 2 chlorine atoms. Please remember that we are not allowed to change the compound, the formula of the compound. We can only put a coefficient in to balance the equation. Let us balance the following chemical equation. We have sodium that reacts with oxygen to give us sodium oxide. Remember, we have to keep this the same. We cannot change the formula of the oxygen or the sodium oxide. So let's start with the sodium. Here we have 1 sodium atom. Here we have 2 sodium atoms. So to balance these 2, we have to put a 2 in front of the sodium. But wait, here we have 2 oxygen atoms. On this side we only have 1 oxygen atom. So we need 2 on this side. We're not allowed to put a 2 there. Remember, we cannot change the formula of the compound. We have to change the coefficient, so we put a 2 in front. But now we can see that here we have 2 sodium atoms, but now we have a 2 in front of the compound. So we have to say 2 times 2 is 4. So we have 4 sodium atoms in the product. So we have to change this to a 4 so that we also have 4 sodium atoms in the reactants. Balance the following chemical equation. We do exactly the same. We compare the number of atoms in the reactants and the atoms in the products. So here we have 1 calcium atom. There we have 1 calcium atom. Here we have 1 carbon atom, and here we have 1 carbon atom. To add to get the number of oxygen atoms, we see here that we have 3 oxygen atoms, and here we have 4 oxygen atoms. So in total we have 7. Here we have 4 oxygen atoms. Here we have 1 oxygen atom and 2 oxygen atoms. So it's 4 plus 1 plus 2, so it's also 7 oxygen atoms. Here we have 2 hydrogen atoms, and here we have also 2 hydrogen atoms. And lastly, we have 1 sulfur atom and 1 sulfur atom. So that means that this chemical equation is balanced as it is.